Hi guys, you're welcome to my channel. Alright, today we are going to study about submersible pump. Okay, alright, so this is a pictorial view of our design. Okay, so first of all, we are going to control water system. Okay, let's get the alright. So this is the pictorial view. Sorry. Okay, so let's cover here. But before then, I want to blind here. This is additional configuration. All right, this additional configuration. So let's blind there for now. Let's understand the function of this particular logic here. Okay. All right. So let me get you the pictorial view. This is the actual representation of the submersible pump wiring diagram. Okay. This is the box, and this is the submerged pump. Okay. All right. Now these are the components that make up that will be enclosed inside this box that make up the starter. Okay. All right. So supply come from here. The supply here will have live, neutral, and earth. The black one is the live conductor. You go to the switch, from switch to overload, from overload to motor. All right. Then neutral come, go to the switch, from switch to capacitor, and from capacitor to the motor. All right. So this is the view. This is the switch look, the front rear, and this is the back rear. Then this is the overload device. Then this one is capacitor. All right. So let's relate this wiring diagram to our schematic. This is the schematic. So this is the supply to the circuit breaker, to the fuse. All right. This circuit breaker is not enclosed here. This protective device. This device is the one you have to install first. The end user has to purchase this differently and they install it and feed this box from here. This particular starter will be feeding from this MCB, okay, in order to protect the short circuit of the circuit and the motor winding deformation. All right, so every other component here is what we have here, apart from this MCB. All right, now let's reconcile this wiring diagram with the pictorial, with the schematic diagram here that we just designed. This is my supply coming to this connector, and this is the supply here come to this MCB. All right, then from this connector to the switch, then from this MCB to my switch. This is the switch, and this is the switch as well. Now from this switch to overload, from this switch to overload here, from here to capacitor. Okay, let's go one after the other. Live conductor move from here, go to the switch, from switch to overload, overload to the motor. All right, this is my live conductor coming from my MCB, from MCB to switch, switch to overload, overload to motor. So they are the same thing, the same continuity. Then I take neutral from here to the switch, that same switch, two-pole switch, switch to capacitor, capacitor to motor. This is my neutral, neutral to switch, switch to capacitor, this is my capacitor, capacitor to motor. Okay, we call this capacitor line, we call this line. Okay, then this is capacitor permanent. This line, this particular circuit here is capacitor permanent. That is three lines we have here. Capacitor line, capacitor permanent, and the line. This one. All right. So we are done with these two. The other one is capacitor permanent. Look at capacitor permanent. This one. From motor to capacitor permanent. So what we have here is exactly what we have here, except this MCB additional device. Now the work of this switch is to put on this, to close this circuit and allow the current to flow. This one is to protect the circuit and also to protect the winding of this submersible pump. Okay. All right. Now this overload here, this particular overload, the function of this one is responsible for protecting the motor mechanism. This is the motor, the submerged pump is two sections. One is having the coil, one is having the mechanical part. Mechanical part is the impeller and the driven. Mechanical part is the impeller and the suction. It suck the water. Then the motor is the prime mover that is going to drive the impeller, being the mechanical side. So if there's a restriction, friction, or resistance coming from the motor, maybe bearing is stuck, bearing is stiff, or one of the shaft is stuck to somewhere, this overload will trip. So that is the work of this overload, to protect the motor from burning out. Because once the mechanical side is having resistance, is struck, so the coil of this particular side of the part of the motor, the submersible pump, will burn out. The resistance, the current will rise, the temperature will rise. Okay. Okay. So this one is responsible to protect the mechanical part. Meanwhile, this other MCB is responsible to protect the coil, the winding side, and the cable of the circuit. So two protection is here. One is MCB, one is overload. All right. Okay. Now capacitor function here, this one is responsible to magnify the voltage. Once the apply voltage come to the wind, if it's low, if the voltage is not up to sufficient range of voltage, this pump will not, the speed, the RPM will not be up to sufficient revolution for that insertion of that water. So capacitor is here to assist that voltage to improve the voltage, increase the voltage for the pump to start. That's why we call it a starting capacitor. Okay. All right. So that is the function of this capacitor here. Now, if we understand the function of this, what we now need to do is to modify this by adding a float switch, make it self-operated system. That's what we're going to do next. So let's minimize this. All right. So this is what we have as a submersible pump starter control. So now, additional thing we have here is where we are going to add our float switch. Okay, so let me show you float switch. This is the physical look of the float switch. This is the float switch. All right. So you come with this suspender, this balancer, and also come with the cord. All right. So the composition of this float switch is this. When you open it, there's what we call limit switch. That limit switch inside is what is responsible for switching the state, the close and open, switching the state depending on the angle inclination of the flow switch. All right, we will come to the tank and we describe how you're going to install that flow switch right inside the tank. Okay, now basically come back here now. Just pay attention, please. This is what we have as the starter motor design. Okay, all right. So now, we want to incorporate a flow switch into the existing starter uh, pump that we have, starter control that we have. The essence is this: we don't want to be putting on the pump and putting off the pump. Okay, we want the system to be self-operated uh, system, such that when the water is filled up, all right, the pump will get disengaged, the pump will shut down. Then when the volume of the water is less than minimum to a certain threshold, then the pump should come up again and refill again. So in that case, the end user don't need to be going to pump the water or shutting down the water whenever the tank is filled up. Okay, so that is the essence of incorporating a flow switch to the tank. So the process of incorporating this is what I'm going to walk you through now. Just pay attention, please. Okay, now let me show you this again. All right, this limit switch, the capacity of this limit switch cannot be ascertained. There is strength, the contact strength inside the limit switch I showed you now. You cannot ascertain the strength of it. So it may be written, let me display it again. Sorry, just hold on. It may be written 30 amps, but the 30 amps may not be okay. I mean, the integrity of that 30 amps, you cannot ascertain it. The current strength, the current carrying strength of that contact may be 6 amps or 7 amps, but the rated figure may be 30 amps. So how would you know? You will not know. So in that case, we don't have to use this switch directly. We have to incorporate it with a relay or a contactor, because the strength of this contact cannot be ascertained. That is the reason why we want to integrate the system with a contactor device. Okay, so just watch me walk you through the. Okay, now this is my contactor. If you cannot find a relay, a good relay, let me show you a relay the way it looks like. Something like this symbol. If you cannot find a symbol of this, a single relay that is up to 30 amps, then use a contactor. Okay, if you cannot, like I said, if you cannot have this, you now use a contactor. And a relay that you must use is going to be two pole, two contact. This contact one, I need another contact here, making it two, because I need to close two lines simultaneously. Okay, so this is a relay. Take it away. We're going to use contactor. All right. Now, contactor, before you also incorporate the contactor, you check the strength of the pump, that submersible pump. Normally come with rating. Let's go to the box. Go to the box. Find out the rating of the pump, whether it's 2 horsepower, 3 horsepower, and so on, or 1.5 horsepower. So based on that, now know the strength of the power rating of your contactor that you purchase, that you will use to interface between the starter and the tank. All right. Now the process is this. This is my contactor. Now ideal operation of this is when this one is closed. Upon closing this switch, the power flow from here to the motor start. Then when you shut down this switch, put it off, this circuit will be open. There's open circuit here, so current no longer go to the motor. Now what we're going to do is we take these two power, live and neutral, bring it to the contactor. So contactor does the closing of this switch. This switch is going to be on off mode, the off position continuously. Put it on off position. So that contactor now take over closing this circuit. This circuit that is supposed to be closing by this switch, contactor will now take over the closing and opening of this circuit by through the bypass arrangement, that is through this other means. Okay, no longer here. It will now close from here. So that is the idea. Now, how do we control the contactor? Just listen. We control the contactor through that limit switch I told you about, this float switch. This is the float switch. Okay. The float switch will be installed right inside the tank. How do we install this float switch? Let me show you again. Just hold on. Now look at it. This float switch here, look at the rolling ball right inside the enclosure. This rolling ball will be rolling, traveling between one point to another point, depending on the angle inclination of this particular device. If this device is turned at angle 90, the ball will roll. So when the ball roll, it will click the limit switch to close or open. All right. So that is how you install this. So if you go to the tank, you make sure that the limit switch is going to be installed at 50% of the tank. And half of the tank is where the switch is going to be situated, the limit switch. That particular flow switch. Sorry. The flow switch, make sure you install it at the center of the tank. I give 5 liter tank here as example to illustrate. So I'm using 5 liter tank, right? Okay, this is the basic, like I said, this is the basic way of controlling water in a residential apartment. This is the basic. We have more advanced method of doing this, but I'm going to start you from the basic before you now go to advanced method. Advanced method is where we use this switch, making it two. One of the switch up, one of the switch down. That's the advanced way. But the basic method conventionally is using this method. Okay, this one is more cost effective. All right. So you're going to position this switch here, and that particular switch comes with 2 cables, but you're going to use 2. It comes with 3 cables. You're going to use 2 out of it. One is an O. Let me illustrate the switch composition by bringing a related switch that looks like it. All right, look at it here. This flow switch, this is the symbol of the flow switch. All right, just watch as I simulate it. Look at it. Look at it. See how it flip. The terminal 11 to 14 is normally open. Terminal 11 to 12 is normally closed. So when water come to a certain level of that limit switch, here we activate. When water go down, we deactivate, activate and deactivate. So that is how the system, this particular switch operates. So this switch is what we are going to use right inside the tank. Okay, so when the level of the water is climbing, when it's coming up, then the position of this will change. This one will be going to a particular angle. When you go to 90 degree, it will off. Then when you slope down to vertical straight, another 45 or so, it will come up again. So that is the function of this. Okay. All right. So like I showed you the rolling ball that is going to be pushing the limit switch right inside the flow switch. Okay. So this switch is what you are going to use to interface the operation of this. So when you mount it here, they have this as a common. You take this, you take the live conductor, sorry, neutral, you're going to be neutral conductor. You're not going to use live conductor. Let's change it here. Let's change this. Yes, yes. Going to be, just hold on. All right, so we're going to change this to neutral. I want this place to be neutral. I'm going to allow neutral to go to the tank instead of live conductor. So this one shouldn't go. Okay, this one shouldn't go. This is my live conductor and this is my neutral conductor. Okay, so what we're going to do is this. Basically, this is my live conductor, this is my neutral conductor. I'm going to use neutral. So let's use neutral. Just hold on. The reason for neutral is because of leakage. So this is neutral. So neutral is coming this way to go to the tank. Neutral is going to the tank, then coming down from the tank and give the coil. Then this one is going to be my live conductor. Okay, right, so take away this. This is my live conductor to activate my coil. So let's do it this way. All right, I think this one is better. So I want my live conductor, sorry, I don't need it thick, I want it smaller. Need a light gauge. This is my neutral to the tank, and this is my live conductor. Sorry. Okay, the reason for this change is because sometimes discover that the switch may be leaking. Water may go into the switch and the leakage will occur right inside the water. So because of that, we prefer using neutral to the limit switch. Okay, so this is my live conductor. Let's just walk it through more. Now this is my live conductor going to the coil of the contactor. All right, then neutral come from here. This is my neutral. Go to the tank to supply the limit switch, then returning back and energize the coil. All right, this is the connection. Then take note again, while fixing this, maintain this, make sure that the length of the cable That is why I give this. I put this. The length of the cable must maintain this. So this is the angle. This is where the water will be allowed to get up to. It should float up to this level, up to this chamber around here. There is this particular flow switch, okay, should be floating around here before the water shut down. So around here. So use this angle, should be around here. Yeah. So it should be around here. Their flow switch should be around here floating before the water shut down. Then the same vein, it should be around here floating before the water start pumping. So it should go below up to this level before it start. So the arrangement of allowing it to be here or here is now dependent on the length of this your cable and the suspension, how you mount this. Okay. All right. So that is the installation of that particular flow switch right inside the tank. From the point of base to where the cable, the access cable from here to here, that is why I give this mark. Then 50% is where you're mounting it, okay, where it will be, so that the length will be sufficient to teeth up or teeth down. Okay. All right. So this is outlet and this is inlet for the tank. All right. So basically, let's see if we can simulate, but this cannot rotate. So we're going to use this lamp to illustrate the function of this motor. So we're going to feed the lamp, this particular lamp, with feed power here, so that this one will illuminate to show that the pump is running. So let's use this one. Let's use this lamp to illuminate, to illustrate when the motor is running. Okay. All right. So let's see. Let's find something straight. This is neutral. This is neutral. Right now, let's simulate this. Okay. So conventional, this is how we operate the motor. This one will be on. Sorry, let me put on this. This one will be on the protective device. Then you operate here. Look at this one on. So it is now assumed that power has gone to the motor. Then off from here, off from here, off from here. Like the conventional way of putting on your motor and off. Okay, the submersible pump. Then if you want to use auto by using flow switch, this one should be off. Let's off it. This one should be off. Now flow switch take over. Look at it. As I press here, okay, then pump will receive power. It begin to pump. When it's up to this level, it will shut down. When you start consuming the water, going down, going down. When water come to this level, look at the level here. When water come to this level, okay, but you still have the power supply active, then the motor will get on, start pumping again. I repeat again, when the water come to the set minimum, the pump will start up again, start pumping. When the water feed up, come to the maximum set point, the pump shut down. And that is the function of this switch. So let's simulate that. I press it. Okay, watch contactor close. Watch the lamp on. I close it this way. It start pumping. When it gets feed up, it shut down. When it's set to minimum level, it start pumping again. All right. So this is the connection process for you to incorporate a flow switch to your sumo pump, right? Okay. Thank you.